Good morning. This is the second lecture of the Principle of Communication subject of third sem Electrical Engineering. Today the topic is amplitude modulation. What is the amplitude modulation? The amplitude modulation of the carrier change is proportionally to instantaneous amplitude of the message signal. Here the carrier signal means high frequency signal and message signal means low frequency signal. So the amplitude of the carrier is changed in proportional to the instantaneous amplitude of the message signal. This is the introduction or definition of the amplitude modulation. Carrier frequency must be relatively higher than the message frequency. We know that here the carrier frequency is high frequency signal and message signal is the low frequency signals. Now, what is the modulation index M for the amplitude modulation? So here the modulation index is the ratio of EM upon EC. It means that the modulating voltage divided by carrier voltage of the signals. What we can also define the modulation index in the percentage form. So the percentage of modulation equal to M multiply 100%. This is the relation of modulation index with percentage form. Now you see in this slide, there are different AM envelope or different type waves. There are total 3 waves. The first wave show the modulating signal or base signals that have the low frequency or have the audio frequency. The frequency range of the audio frequency or modulating frequency is hertz to kilohertz or maximum 3.5 kilohertz frequency of the modulating signal. What second wave show the carrier signals. Carrier signals means high frequency signals. The frequency of carrier signal may be vary from kilohertz to up to megahertz. So the carrier frequency signal is the high frequency signal and modulating frequency signal is the low frequency signal. Now we superimposed of these two signals and find the resultant signal, that is the waveform number third, that is the resultant modulated signals waveform or after modulation waveform. You see in waveform third, here this wave is the mixing of modulating signals and carrier signals, and the in this wave the modulation or amplitude is vary according to the instantaneous signal. So this is the resultant modulated amplitude modulated signal, and here we see that in starting there is no modulation because the no variation of amplitude of modulating signal. What next? The amplitude modulation double sideband frequency envelope. So the variation of the amplitude of the signals. So this show the resultant signal of the amplitude modulation. There are different frequency spectrum in modulation system. Here we see the x-axis divided into different frequency components, and we take the voltage on the y-axis. So Fc is the center frequency or carrier frequency of the signal, and FUS is the upper sideband frequency, and FLSB is the lower sideband frequency. The voltage of lower side band frequency equal to MEC upon 2, where M is the modulation index, and the voltage for the upper side frequency, the voltage for the upper side band is the MEC upon 2, where M is the modulation index and EC is the carrier voltage. So this is the relation between the voltage versus frequency in different frequency spectrum form. Now we see in this graphs, we take the power of modulating signal on y-axis and frequency component on the x-axis, and there are different frequency component, same as we see previous slides. But the power of lower side band frequency and upper side frequency is given here. So the power of lower side band frequency is the m square pc upon 4, and for the power of upper side band is the m square pc upon 4. Here pc is the carrier power of the signal. So the total carrier frequency equal to EC square upon 2R. This is the total power carrier frequency. So this is the sum of the lower side band plus upper side band power. Now we see here the different other amplitude modulation system which is generally used in communication system field. First one is the suppressed carrier system. Next one, double sideband DSB system, and next single sideband system SSB, and SSB with pilot carriers, and independent sideband ISB system, and last one is vestigial sideband VSB system. There are the other AM system which is generally used in communication systems. We see here in this slide, there are different same waveforms. First waveform, so the modulating signals waveform. Second is the modulated waveform signals of the AM. And third one is the more or 100% modulated waveforms in which 100% modulation occurs. And last one, D is the different waveforms of single sidebands and upper sidebands. So there are total 4 waveforms here. SSB, single sideband, What is the advantage of single sideband? There are some advantage of SSB. First one is lesser power consumption. Second one is conservation of bandwidth. What is the bandwidth? Bandwidth is the difference of two frequency, higher frequency minus lower frequency. That is the difference of two frequency. That is the bandwidth. And next one is the noise reduction. This is also advantage of SSB. And last one is the less fading. Less fading means if we want to transmit a signal from one point to another point or from source to destination, if the 100% signal is not received at the destination point, it means some signals are losses between source to destination distance. So this is the called as a fading. So there is the less fading in SSB or single sideband system. What here some disadvantage of SSB? So first disadvantage is required complex receivers because the circuit diagram of receiver which is used in SSB is very complex. And next one advantage is the at the receiver coherent carrier has to be generated. This is the also disadvantage. In case of pilot carriers, at the receiver end, it has to be boosted properly. So there are three disadvantages of the SSB system, single sideband system. Now we discuss about the different modulators which is generally used for modulation process. There are different type of amplitude modulators. First one is square law modulators. Second one is switching modulators. Third one is transistor modulation. And the last one, transistor modulators, also divided in three types: low level, medium level, and high level. So these are the some amplitude modulators. And there are also different types of modulators. There are generally two types: balanced modulators and SSB generations. The first, balanced modulators divide into three parts. First one is balanced ring modulators. Second one is balanced bridge modulators. Third one is transistor balanced modulator. And last and fourth, FET field effect transistor balanced modulators. So balance modulators divide in four parts, four types. Next one is SSB generation, single sideband generation. There is two types, the filter method and phase shift methods, which is generally used for these two methods to generate the single sideband generation process. Next, demodulators, distortion and reception. These are the some other parts of the modulation system. Demodulators, it perform the opposite function of the as a modulators, and some distortion are arising in processing of modulation system. And what is the received signal at the receiver end. So there are demodulators, distortion and deception. So now AM demodulators, AM amplitude demodulators divided in two types. First one is rectifier demodulator. Second one is envelope detectors. And next one is detector distortion. These are also two types: diagonal peak clipping and negative peak clipping. And next one is the single sideband reception, SSB reception. That is also two types. First one is coherent detection and second one is reception with pilot carriers. This is the block diagram of the part of transmitter or modulation process, in which diagram we see here the RF carrier oscillator, generally used carrier oscillator, which is generate the high frequency signal, RF carrier signals, and then this signals applied to the buffer amplifier, and the function of buffer amplifier to increase the strength of the carrier signals, and then buffer amplifier transmit or apply to this signal to the carrier driver, and carrier driver applied the this signal to the modulator, and this is the modulator, and here a modulating signal source which is generally used for generate the modulating signal or base signal, and this signal also applied to the band pass filter. Band pass filter filter the a particular band of particular range of frequency signal, and this signals applied to the pre-amplifier. Pre-amplifier means if signals have low strength, then the pre-amplifier increase the strength of the this baseband signal or modulating signal. Then this signal applied to the modulating signal driver, and modulating signal driver applied to the modulator. So in modulator there are two signal mixing. One is carrier signal and second is the modulating signal or baseband signal. Then after mixing or modulator process, next this signal applied to the band pass filter, and that band pass filter filter the signal a particular frequency range, and this signal applied to the linear intermediate power amplifier, and the power amplifier function increase the strength of the signal to a particular level, and this signal applied to the linear final power amplifier, and linear final power amplifier work the linearity of the incoming signal, and this signal also applied to the band pass filter, and this filter pass the a particular frequency signal, and then after this signal applied to the coupling network, and this is the output network, and after this uh, network or receive the signal at this point, the signal is transmitted through the antenna to the free space, there are we can use the different type antenna, just like Yagi Uda antenna, micro strip patch antenna, or parabolic antenna. Basically, transmission process, we use the antenna for transmitting the signals to the free space. So this is the block diagram of the transmitter, which is used for modulation process. There are different uh, blocks and different process occur here, and last and finally the signal is transmitted to the free space for the transmission. Now we come on the high level double sideband frequency transmitter. This is the high level transmitter. So we see here a modulating signal source, same band pass filter and preamplifier, and modulating signal driver amplifier, then modulating signal amplifier, and this signal applied to the AM modulator and output power amplifier. And next we take the another signal is the RF carrier signal, which is generated by the RF carrier oscillators, and this signal applied to the buffer amplifier, and buffer amplifier amplify this signal to a particular level and then transfer to the carrier driver, and after carrier driver this signal transmit to the carrier power amplifier. Power amplifier also increase the strength of the signal. There are maybe different type power amplifier, class A, class B, and class C. What we are generally used here, class A push pull amplifier or class B push pull amplifier, and these are two signals mixing in AM modulator and output power amplifier. Then output of this power amplifier, we applied this output signals to the band pass filter, and band pass filter the a particular frequency range of the signal, and then to the output network or matching network, and this matching network, this is the output network, and here the output is signal is received, then output signal is transmitted to the free space with the help of the antenna. So this is the high level double sideband transmitter block diagram. Now we come on the single sideband transmitter, which is generally used for single sideband signals transmitting purpose. Single sideband suppressed carrier transmitter BPF is used to remove the other sideband signals. BPF means band pass filter. We see in this block diagram there is low frequency crystal oscillator, and one is the upper sideband crystal and second one is the lower sideband crystal. So we can use for low frequency crystal oscillator as a upper sideband crystal, or also we can use lower sideband crystal. Next, balance modulator. This signal applied to the balance modulator, and balance modulator receive this signal and This signal again applied to the sideband pass filter. Sideband pass filter. This sideband pass filter, what is the function of sideband pass filter? It removes the one side of the one side suppress of the signals. It may be upper side or maybe lower side. And this sideband pass filter signal applied to the next balance mixer, and balance mixer also we apply to balance mixer a crystal oscillator. The crystal oscillator generates the high frequency signal, and this high frequency signals and low frequency crystal oscillator signals, both signals are mixed here in balance mixer, and after mixing the output of balance mixer, the signal again applied to the linear power amplifier, and this linear power amplifier increase the strength of the signal and provide to the signal linearity to the signal. And next one is the output stage or matching network. And here the signal, output signal is received, and this signal is transmitted to the free space with the help of antenna. So this is the SSV transmitter, which is used for the single sideband transmission purpose. Now we discuss in different methods of modulators or transmitters. So there one is the phase shift method, which is used for modulating process or in transmitter. Now we see here in this block diagram, we choose a audio input signal. The range of audio input signal have the frequency hertz to kilohertz or maximum 3.5 kilohertz. This is the range of the audio signals. Now this signal is applied to the balance modulator, and again another signal which is generated by the crystal oscillator, that is the high frequency signal, also applied to the balance modulator, and we use here 90-degree phase shift here, and this phase shift, the signal is shifted by the 90-degree with the help of this phase shifter, and after phase shifting the signal is applied to the summing amplifier, and here the two signals are summing, and after summing, and what is the resultant signals, the output of the this summing amplifier is applied to the linear power amplifier, and this linear power amplifier provide the linearity to the input signal and increase the strength of the signal of which is received by the summing amplifier. And next, this signal is transmitted to the free space with the help of antenna. So this is the phase shift method modulator, in which a particular or 90-degree phase shift is generated between two signals, One signal is audio signals and second signal is the carrier signal. These two signals have the 90-degree phase shift to each other. So this method is called the phase shift method for the modulating process. Now we come on SSB transmitter with pilot carriers. This is the another technique for single sideband transmitter with pilot carriers. So we see here we take the audio input signal and apply to the balance modulator, and also another signal is applied to the balance modulator which is generated by the carrier oscillator which have the frequency of 100 kilohertz. And then after balance modulator, the signal is applied to the upper side band filter. So the filter frequency is 100 to 104 kilohertz. This is the frequency range 100 to 104 kilohertz. And this signal applied to the summing network, and also another signal carrier insertion attenuator which generate the 100 kilohertz frequency signal is also applied to the mixing network. And after mixing network, the output of mixing network is applied to the balance modulator. This is also as a mixer, and this mixer also we apply to this mixer also another carrier signal which is generated by the carrier oscillator which have the frequency of 2900 kilohertz or 2900 kilohertz. And these two signals are mixed in balance modulator, and after mixing in balance modulator, the output of the balance modulator is applied to the band pass filter which have the band frequency range of the 3000 to 3004 kilohertz. This is the band pass filter frequency range, and this band pass filter, the signal from here applied to the linear power amplifier which have the a very large frequency which is the 3 megahertz frequency, and this linear power amplifier provide the receiving signal linearity and increase the strength of the signal, and then this signal is transmitted or transmitted in the free space with the help of antenna. So this is the single sideband transmitter with pilot carrier signals. Here we use the pilot carrier which have the frequency of 100 kilohertz. So this is the SSB transmitter with pilot carrier. Now we come on the super heterodyne receiver. This is the part of the receiver. So we see here in this block diagram a signal received by the antenna, receiving antenna. This antenna is called as receiving antenna, or this antenna may be parabolic antenna, micro strip patch antenna, or Yagi Uda antenna. This antenna receives the signal from the free space in the form of electromagnetic waves, and this signal applied to the radio frequency amplifier, which signal is received from the antenna, and this signal which from the received from the antenna is applied to the RF amplifier. And the function of RF radio frequency amplifier is increase the strength of the this received signal, and then this signal is applied to the mixer. In mixer there is a one RF signals and another signal is the carrier frequency signal, which is generally generated by the local oscillators, which is generated by the local oscillators, which generate the high frequency signal. And after the mixing of these two signals in mixing network, the output signal of the this mixing network is applied to the IF amplifier or intermediate frequency amplifier. This IF amplifier select a particular frequency from the mixing network, because in mixing network there are two signal of mixing. One is RF signal and second is the carrier frequency signal. So this IF amplifier select or choose a particular frequency of signal, and that signal choose by the IF amplifier is again applied to the detector. This is the next network, and after detection of this IF signals, and this signals again next applied to the audio frequency amplifier. Basically this is the receiving part of the receiver or output part of the receiver, and then applied to the speaker. Speaker we have as a load here, and we can receive the original signal which is transmitted by the transmitter, and after by receiving super heterodyne receiver, and finally we receive the original signal which is transmitted by the transmitter by the different modulation technique, and last and finally we receive the original signal or audio signal or baseband signal or modulating signal. So this is the output stage of the super heterodyne receiver where the output is received. Now we come on the single sideband pilot receiver. In single sideband pilot receiver, the antenna receives a signal of the 3 megahertz frequency signals. This signal is applied to the upper sideband filter, which have the frequency range of 100 to 104 kilohertz. And also this signal is applied to the pilot carrier filter, which have the frequency of 100 plus minus 0.1 kilohertz. And then also this pilot carrier signal applied to the phase lock carrier oscillator. The phase lock carrier oscillator select this signal frequency and log them a particular frequency, and this frequency suppose log at the 100 kilohertz, and this frequency signal applied to the balance modulator, and balance modulator also receive a another signal from the free space, and now there is two signal in balance modulator. So balance modulator product dip modulator behave as a product demodulator, because there are two signals are product, and after producting, this modulator applied the signal to the low pass filter, and the low pass filter have the frequency range up to 0 to 4 kilohertz. And after low pass filter, the signal is filtered by the low pass filter and applied to the audio output, and we receive the output signal at the termination point or load point. Here we receive the original signal which is transmitted by the transmitter, and we receive the audio signal in SSB pilot receivers. Now we see in this block diagram, this is the total transmitter or receiver block diagram. This is the mixing of transmitter part and receiver part, and this is the total transmitter receiver block diagram of the any modulation technique and demodulation technique system. In this block diagram, the signal is received from the antenna, and this signal is applied to the RF amplifier, which have the 1.5 megahertz frequency, and also a automatic gain control is applied to the RF amplifier, and this signal also applied to first mixer, and a first mixer, and this is the one signal, and a second signal is applied to, which is generated by the crystal oscillator, which have the 17.855 megahertz frequency, and this signal applied to the frequency tripler amplifier, and this after this amplifier the signal is applied to the frequency tripler amplifier, and this signal is mixed with the first signal, and after this a first IF amplifier also used for this mixing signals, and this signal is also applied again first RF filter, which have the 10.7 megahertz frequency, and next this signal is applied to the second mixer and also second mixer, and another signal here mixed from the second oscillator crystal, which have the frequency of 11.165 megahertz. So this is the second mixer, and there are total two mixer, first mixer and second mixer, and in this both mixers there are mixing of two different signals. One is low frequency signal and second one is high frequency signal. Basically low frequency signal is audio frequency signals, and high frequency signal is generated by the crystal oscillators, and then after second mixing, the signal is applied to the second IF, which have the 465 kilohertz frequency, and also this signal is applied to the automatic gain control detector, and this automatic gain detector applied the signal to the RF amplifier, and again second IF filter amplifier received the signal from the second IF network, and this after second IF filter, the signal applied to the detector, and detector means detect the signal and what is the output signal, and then this signal is applied to the audio frequency amplifier or original signal receive the at this AF amplifier, and we use the speaker as a load, or the original signal is received at the point of AF amplifier. So this is the transmitter and receiver mixing diagram of both transmitter and receiver, where a signal is received and modulated and transmitted and again demodulated and receive the original signal at the receiver network. This is the total transmission and receiving process of the amplitude modulation system. Here are some receiver parameters which we consider in receivers for their performance purpose. First one is selectivity, second one sensitivity, third one dynamic range, fourth one is fidelity, and next one is bandwidth, and last parameters is noise temperature and equivalent noise temperature. These are the some receiver parameters which are considered to performing or performance, deciding the performance of the receiver. Again, we see here in this block diagram, there is a carrier signal, and this signal applied to the two mixing network, and signal is also shifted by 90-degree phase shift by the 90-degree phase shift network, and this after mixing of first mixing network, signal applied to the low pass filter, and another output of the second mixing is applied to the also low pass filter, and these two signals are again mixing both, and then after mixing the output signal is applied to the loop filter, and loop filter output applied to the VCO voltage control oscillator. This is the process of in loop process of the carrier signals, which is shifted by the 90-degree phase shift. So this is the carrier process in which 90-degree phase shift generated. So there are some books which cover this topic. Book first is Principle of Analog Communication, author is George Kennedy. And second book is Analog Communication System, author is B.P. Lathi. There are some multi-choice questions which is very helpful to understand this topics and clear the concept of this topic. So please attempt and solve these multi-choice MCQ questions, and these are very important for concept clear purpose. So please attempt these different multi-choice questions. Thank you. Thank you.